9.3 Formulas and examples. The mean of the sampling distribution of x bar is mu x bar equals mu. The standard deviation of the sampling distribution is the standard deviation divided by the square root of n. The population must be at least 10 times the size of the sample. The central limit theorem is if n is big enough, the sampling distribution is approximately normal. The more skewed the population distribution, then the bigger n must be for the sampling distribution to be normal. So an example problem is women's heights are normally distributed. The mean is 64.5 and the standard deviation is 2.5. Find the probability that x is greater than 66. So to find the probability that x is greater than 66, first you know that the mean is 64.5. And then the standard deviation, you have to take the standard deviation given, which is 2.5, and divide it by the square root of n, which is the square root of 10, and you get 0.7906. So then you're going to draw it out, and you're going to write the mean, which is 64.5 in the middle, and then the standard deviation at the top, which is 0.7906, and then you're going to put 66 down and then shade to the right because you want x to be greater, all the values greater than 66. Then you're going to do normal CDF, and you're going to do lower bound, which is 66, to infinity, which is your upper bound. Then you're going to put your mean, which is 64.5, and then your standard deviation, which is 0.7906, and you get 0.0289 as your final answer.